Okay, so the nice thing with this problem is that even though there are two different things you need to solve, you can actually use the exact same tree diagram to solve A and B. So you only need to make the tree diagram once, and then you're able to analyze that tree diagram to find the favorable outcomes that you're looking for in A and then the favorable outcome you're looking for in B. So in order to set this up, and I'm going to start it on here, but I've got one created by hand. In order to set this up, you're going to want to have two different columns. So one, that's not pi, it's die. One is the die, and the second is the spinner. So those are the two things that are happening. And so what you're going to do is you're going to have, what could you do when you roll a die? Well, I could end up with a 1, 2, 3, 4, 5, or 6. And then, so if I roll a 1 on a die, I have four different possible outcomes of what could happen on this spinner. I've got a green section, a purple section, an orange section, and a yellow section. So I'm going to show you the tree diagram that I made by hand that I was able to keep more neat and tidy and spaced out so that we can all understand what I'm writing a little bit better. So that will represent the information we need. All right, so for both of these problems, I do need to know what my denominator is going to be. And so in order to find my denominator, we're going to do as we did before, and that is we're just going to count the total outcomes in our final row of our tree diagram. And looking at those final outcomes, I can see that I've got groups of 4 and I have 6 of them. So my potential or possible outcomes, which is of course always the denominator, is 24. Now we're going to look at A and B, and we will solve for what our favorable outcomes are. Question A asks me, what is the chance that I'm going to roll a 3 on my die and I'm going to spin a yellow? So right away, I can eliminate a bunch of things from my chart. I can eliminate everything that's in the 1, everything that's in the 2, everything that's in the 4, everything that's in the 5, and everything that's in the 6, because I need to roll 3. So all of those are out. But as far as then the rest, I'm going to analyze if I roll a 3, what is my desirable outcome? I need to spin a yellow. And there's only one scenario where that happens. I get a 3 and I get a yellow. So in question A, I only end up with 1 out of 24 possible outcomes of doing what the favorable or the desired outcome is in A. It's a 1 out of 24. Let's look at B now. So in B, I am being asked, what is the chance that I'm going to roll a number that's less than 3 and I'm going to spin a purple? So I'm just going to get rid of some of this work that I have already done so that we can clearly analyze this for B. All right, so roll a number less than 3. So 1 is good, 2 is good, 3 is not good, it's not less than 3, neither is 4, neither is 5, neither is 6. So everything in all of these branches is out. It's no good for the scenario we're looking for. So now I'm going to analyze the 1 and the 2. So I'm looking to roll a number less than 3. So I've got my 1 and 2, and I'm looking to spin a purple. So my P is my purple. So this here and this here are my only two scenarios where I am able to get that desirable outcome of rolling a number less than 3 and spinning a purple at the same time. So 2 out of 24, which I'm going to reduce to 1/12. And to include our decimals and percentages, a 1 out of 24 chance is about a 4% chance, which is 0.04. And a 1 in 12 chance is about an 8% chance, which is a 0.08.